Today in science, we're on page 126 in our textbook, and it's just at the end of our chapter where we've just finished up studying in chapter 4 the behavior of fluids and the science behind the different types of matter. We're looking at this specific article called Oops, Accidents in Science. It's titled as Incredible Stretching. You'll see that on your screen. It's all about the chemistry of silly putty. How did we come to actually discover this kind of crazy substance that has properties of a liquid and of a solid during this time of World War II? Let's read. During World War II, when natural resources were scarce and need for the war effort, the U.S. government asked an engineer to come up with an inexpensive alternative to synthetic rubber. While researching the problem and looking for solutions, the engineer dropped boric acid into silicone oil. The result of these two substances mixing together was a goo. Because of its molecular structure, the goo could bounce and stretch in all directions. The engineer also discovered the goo could break into pieces. When strong pressure is applied to the substance, it reacts like a solid and breaks apart. Even though the combination was versatile and quite amusing, the U.S. government decided the new substance wasn't a good substitute for synthetic rubber. A few years later, the recipe for the stretch material fell into the hands of a business person who saw the goo's potential as a toy. The toy maker paid $147 for the rights to the boric acid and silicone oil mixture. In 1949, it was sold at toy stores for the first time. The material was packaged in a plastic egg, and it took the U.S. by storm. Today, the acid and oil mixture come in multitude of colors, and almost every child has played with it at some time. The substance can be used for more than child's play. Its sticky consistency makes it good for cleaning the computer keyboards and removing small specks of lint from fabrics. People use it to make impressions of newspaper prints or comics. Athletes strengthen their grips by grasping it over and over, and astronauts use it to anchor tools on the spacecraft in zero gravity. All in all, a most excellent idea. Now, the chemistry of silly putty is kind of displayed here. It's a little bit further advanced in terms of what we understand in terms of the study of how things are put together, but we can take a couple pieces of information, and then I want to give you an opportunity as your art class today that relates to science to go ahead and make something similar to this in the form of slime. I'm going to post a video of instructions how to make a really simple slime recipe, and you're welcome to enjoy that, because if we were in class, that's what we'd be doing. It says here that silly putty is an odd substance. It can slowly stretch out but snaps if pulled apart with greater force. It can be molded into shape but bounces and rolled into a ball. What's behind these strange properties? Well, here's a quick look at those chemical properties and their explanation. What's it made of? It's called this thing polydimethylsiloxane, or PDMS. This is the simplest member of the polymer family known as the silicones. PDMS is viscoelastic. Viscose, that's viscosity, and elastic, stretchy. This means that it acts like a viscous liquid and flows over a long time scale. However, over short time scales, for example, being rolled into a ball and thrown on a hard surface, its behavior is elastic and it will bounce back. How does this work? Well, the presence of PDMX, that's the polydimethylsiloxane, alone and its viscoelasticity doesn't fully explain how silly putty behaves. Another ingredient, boric acid, also makes a telling contribution. The boric acid helps to create cross-links between the adjacent polymer chains. These give silly putty its putty-like nature, also explain its strange behaviors. So here's what that polydimethylsiloxane looks like, where you've got the silicone that's attached between oxygen molecules, and then you've got the rest of its contributions being connected. So here's what the chemical structure of this item looks like. And then you've got boric acid that kind of holds this whole thing together. So it has properties like a liquid and properties like a solid. Pretty cool. What I'd like you to do, if you are willing and if you'd like to, as part of our art class, go and watch this video that Mr. Shane has posted on our class page. It's how to make the best kid-friendly slime. It actually doesn't use the boric acid that's talked about in silly putty. It makes a kind of different material with some really simple ingredients. That's our art class for today. It's completely optional as it relates to science class. I hope you have a chance to watch this video and enjoy.